In March 2025, a computer scientist opened a JWST image so deep, it showed galaxies from the beginning of time. He counted how each one spins. The numbers should have split evenly. They did not. Either our universe is spinning, or we are inside something that is, your galaxy included. The scientist's name is Lior Shamir. He works at Kansas State University, and in early 2025, he published one of the strangest and simplest results in recent astronomy. He didn't need a new telescope. He didn't need new physics. He just needed the deepest picture ever taken of the early universe, and a way to look at it without flinching. The picture came from something called JADES, the JWST Advanced Deep Extragalactic Survey. It is one of the flagship projects of the James Webb Space Telescope, aimed at a tiny patch of sky near the Southern Galactic Pole. Webb sat in the dark above the Earth and let ancient light fall onto its mirrors for days. When the exposure was complete, the image contained thousands of galaxies from a time when the universe was still young, some of their light more than 12 billion years old. Shamir did something almost childishly simple with that image. He asked, which way does each galaxy spin? Spiral galaxies have arms. Those arms curl. From our point of view, they either wind clockwise or counterclockwise across the sky. It's not a subtle property. You can see it with your own eyes if the picture is sharp enough. In a random universe, the count should be almost dead, even, half one way, half the other, within a small margin of statistical noise. That's what modern cosmology predicts, and that's what modern cosmology needs, because here's the assumption on which almost every calculation about the cosmos quietly depends. It's called the cosmological principle, and it says something so basic that it sounds harmless. At large enough scales, the universe looks the same in every direction. No preferred spot, no preferred axis, no cosmic up or down. Take a big enough patch of sky, and it should statistically match any other big enough patch of sky. That principle is not just decoration. It is the reason the equations of general relativity are solvable for the universe as a whole. It is the reason we believe in a smooth Big Bang, in a uniform expansion, in the age of the cosmos, we tell schoolchildren. If the cosmological principle is wrong, a lot of the story we tell about how we got here becomes negotiable. So Shamir ran his algorithm on 263 spiral galaxies in the JADES field, everyone clear enough to give a confident answer about which way its arms turned. And this is what he found. 158 of them spun one way. Only 105 spun the other, roughly 60% versus 40%. In a field where the split should have been 50-50, that may not sound dramatic. 60 against 40, a minor lean. But you have to understand the scale of what a lean like that implies. The statistical significance of the imbalance is around 3.4 sigma. In everyday language, that means the odds of getting a split that lopsided by pure chance are less than 1 in 1,000. Now I want you to picture where you're sitting. Look up, past your ceiling, past the atmosphere, past the local stars. You are riding on a spiral galaxy right now. The Milky Way has arms, and it has a direction. To some hypothetical observer in the JADES field, you are just one more spinning disk. This isn't an abstract debate about faraway objects. Your galaxy is a data point in somebody else's spreadsheet. So the first thing any careful scientist does with a result like this is try to make it go away. And the most obvious way to make it go away is to blame chance. Maybe Shamir just got unlucky. Maybe this field is a fluke. Maybe if you point Webb somewhere else, the numbers balance out. That escape route closes almost immediately. 3.4 sigma is not luck, and this is not the first time the signal has appeared. Shamir saw it in earlier JWST data in 2024. He saw a smaller version of it years ago in the Hubble Ultra Deep Field. Similar hints show up in massive Earth-based surveys, SDSS, Pan-STARRS, DSI, different telescopes, different sky, same lean. So it is not a fluke. Something is really there. And here's the detail that refuses to leave the room. The JADES field, the patch of sky where the asymmetry is loudest, sits right next to the Southern Galactic Pole. That is not a random location. It is the exact place on the sky where a certain kind of observational trick would be strongest. A trick involving our own motion through the galaxy, which means the mystery just quietly changed shape. Before we accuse the universe of secretly spinning, we have to rule out something simpler. And there is a simpler explanation. It just happens to be almost as unsettling. Start with the algorithm itself. Anytime somebody counts galaxies by spin, the first thing skeptics ask is whether the counting method silently prefers one direction over the other. Maybe the software is more sensitive to a particular twist. Maybe the way the image is processed subtly favors clockwise curves. Shamir anticipated this. His method is symmetric. You can flip the image, run the same code, and it still gives a consistent answer. He has already published tests on data from SDSS, Pan-STARRS, DESI, all cross-checked, all showing the same fingerprint. If the algorithm were biased, that fingerprint would collapse. When the sky was flipped, it doesn't collapse, so the counting is honest. The lean is real. That leaves one clean, boring, physically respectable escape route. And here it is. Our own Milky Way is spinning. The sun swings around the galactic center at roughly 200 kilometers per second. That motion is small compared to the speed of light, but it isn't zero. And because of the Doppler effect, the same phenomenon that changes the pitch of a passing siren, light from galaxies whose rotation runs opposite to ours arrives slightly bluer, slightly brighter, slightly easier to see. Light from galaxies rotating the same way as ours arrives a touch dimmer. That effect is real. It is not exotic. It is textbook physics. And near the galactic pole, exactly where JADES points, that effect is strongest. You can already feel where this goes. If counter-rotating galaxies are systematically a little easier to detect than co-rotating ones, then any deep survey will count more of them. Not because the universe is asymmetric, but because we are the ones who are moving. It would mean the imbalance is not out there. It is a reflection of us. This is the answer that saves the standard model. Elegant, deflating, almost too clean. And here comes the problem. The Doppler effect on galaxy brightness is not a large one. It nudges. It doesn't shove. Working through the numbers, the bias should produce a small excess. A few percent, perhaps. Instead, JADES shows a 50% difference. 50%. The observational bias explanation is real, but it is not big enough. Not by a wide margin. Somewhere between what the effect can plausibly produce and what Webb actually recorded, there is a gap the size of the anomaly itself, which forces a very awkward next step. Because if you insist that the Doppler explanation still applies, if you refuse to abandon it, the only way to make the numbers work is to admit that the Milky Way's rotation has a much larger influence on our observations of the deep universe than anyone previously believed. Which sounds harmless until you follow the chain. If the influence is larger, then the brightness of distant galaxies is systematically wrong. If their brightness is wrong, their distances are wrong. And if their distances are wrong, then the way we measure the expansion rate of the universe is wrong. Every rung of the cosmic distance ladder, the framework we use to say how far, how old, how big, becomes suspect. Shamir himself has pointed at this directly. He has said that if the recalibration is needed, it might quietly explain two of the deepest embarrassments in modern cosmology at the same time: the Hubble tension, the growing disagreement over how fast the universe is expanding, and those impossibly old, impossibly massive galaxies Webb keeps finding in the early universe, the ones that shouldn't exist, because they appear to be older than the cosmos that contains them. You see the trap now. The boring answer isn't boring. The boring answer says a chunk of modern cosmology has been reading the sky through a distorted lens for decades. Saving the standard model requires demolishing it, and so, almost against your will, you begin to take the other explanations seriously, the one Shamir mentioned in a single quiet sentence when the paper came out, that the universe was born rotating. This is not a slogan. There is a peer-reviewed theoretical framework where it is not only possible, it is expected. It was developed most persistently by a physicist named Nikodem Popławski at the University of New Haven, using an old, half-forgotten variant of general relativity, Einstein-Cartan Kibble gravity, that adds a subtle property called torsion into the fabric of spacetime. Most physicists never encounter it. Einstein himself once set it aside. That torsion does something remarkable. At the crushing densities inside a collapsing star, it pushes back. Hard enough, in Popławski's calculations, to prevent the singularity from ever forming. Instead of a point of infinite density, the collapse bounces. A new universe blooms inside the event horizon, and it inherits, from the star that made it, one small ghost of a memory: its spin. Now pause with me on what that scenario actually claims. When a massive star ends its life and forms a black hole, everything crossing the event horizon is compressed toward the center. Standard physics says that center becomes a singularity, a place where the equations stop working. Popławski's math says that instead, at densities beyond anything we can create in a laboratory, torsion becomes overwhelming. Matter cannot compress any further, and the collapse rebounds. From outside, the black hole still looks like a black hole. From inside, a new region of space-time expands. New particles pour out through quantum production. New matter, new radiation, potentially a new period of inflation. That expansion, seen from within, would look almost exactly like a Big Bang. I want you to sit with that image. Every black hole in our own night sky, in this reading, could be the birth event of a universe we will never see. And our own Big Bang, the moment we treat as the origin of everything, could simply be the interior view of a collapse that happened in some larger cosmos that will never know we exist. None of this is proven. That has to be said clearly and often. Popławski's framework is speculative. It is mathematically consistent, published, taken seriously by a small number of theorists, but it is not the consensus picture of cosmology. The consensus picture is still a single, self-contained Big Bang with no parent. What changed in 2025 is that a real observation, taken by a real instrument, produced a pattern that the speculative framework had quietly predicted for years. That pattern is a preferred axis, a cosmic direction, because if our universe formed inside a rotating black hole, it would inherit the spin of that parent, and galaxies forming inside it would carry a faint memory of that inherited rotation, which is, functionally, what the JADES field is showing. Now let me separate the layers carefully, because this is where sensational headlines start distorting what the evidence can actually do. The measurement itself is solid, 158 to 105 at 3.4 sigma in a deep field near the Southern Galactic Pole. That much is not in dispute. The claim that this asymmetry is cosmological, that it reflects the universe rather than our instruments or our motion, is a step beyond the measurement. That step is contested, and honest scientists on both sides of it are still arguing. The claim that black hole cosmology is the correct explanation is a further step still. That is a hypothesis, not a discovery. 3.4 sigma is a compelling result. It is not the 5 sigma that physics demands before it uses the word confirmed. The metaphor that keeps returning here is a room with no windows. In Chapter 1, we walked in and described the room, the field of galaxies, the counted spins. In Chapter 2, we noticed that everything inside the room drifts subtly the same way. Now in this chapter, we begin to suspect that the room itself might be turning, and that we have never been able to see the walls. If we are inside a black hole, then the boundary we can never cross, the event horizon of our own parent cosmos, is not somewhere out beyond the farthest quasar. It is the observable universe itself. The wall isn't distant. The wall is the edge of what we can see, in every direction, all at once. So let me answer the title honestly, the way I promised at the beginning. No astronomer has proven that we live inside a black hole. Nobody has walked to the edge of anything. Nobody has photographed a parent universe. Nobody has demonstrated that torsion is a real feature of gravity. What has happened is smaller and, in a strange way, more important. A measurement now exists that would be difficult to explain in a perfectly symmetric universe, and would fit naturally in one that inherited a spin from something larger. For the first time, a question that used to be pure philosophy has a data point attached to it. Return with me one last time to that image. 263 ancient galaxies scattered across a small square of sky near the Southern Galactic Pole. Light older than our planet, older than our star, falling for days onto a mirror parked 1,000,000 miles from Earth. When we started, that image was a picture of the early universe. Now it is something else. It might be the first faint fingerprint of a direction the cosmos itself is turning. It might be the trace of a rotation older than the Big Bang. The next generation of surveys will decide. Euclid is already mapping billions of galaxies. The Roman Space Telescope will follow. More JWST deep fields are coming. If the asymmetry survives them, if it deepens instead of dissolving into an observational quirk, then cosmology will have to change, not gently, structurally. And that leaves one precise question, the one I want you to carry with you when you close this video. If our universe has an axis, if it truly is spinning, then what is it pointing at? And what is on the other side of it?